Hello there, Cardinals. It's me, Mr. Ernst, and today we are going to be taking a look at rational and irrational numbers. Rational and irrational numbers are basically two different types of numbers that we've already been working with, or we started working with, but now we're actually going to define what they are so we know how to work with them in the future. Okay? So, last week we were looking at estimating the square root of non-perfect squares. For example, our very first one was the square root of 2. That looks like it came out to roughly, we estimated about 1.3, okay? I'm going to actually put this into a calculator to see what we get when we look at it in a calculator. So, when we have this into a calculator, if we do a regular number, like let's say a perfect square, like 4, and we take the square root of 4, we get the number 2. The square root of 4 is 2, a nice clean number. However, when I take a number like 2 and I take the square root, I get the number 1.4142135623750488016887242097. And the crazy thing is, the number doesn't actually end. This is an infinite number. It will go on into infinity. So you can see we were pretty close. 1.3 was our estimate, 1.4 is the actual. So our estimate was pretty close. But this is an infinite number. The number does not end. The calculator does, but the number itself does not end. And that is because this is an irrational number. An irrational number. Okay? So let's talk a little bit more about what this means. And we're going to show some examples here. So I'm going to get rid of this. I'm going to clear my drawing layer here. And let's go ahead and talk about what it means for a number to be rational or irrational. The very first one, rational. This means that a number can be expressed as a fraction. That is kind of the definition of rational. It is a number that can be expressed as a fraction. You have, let's say some number x over some number y. And maybe that's not the best thing to do because that looks like the reverse of slope right now. So some number x over some, or some number y over some number x. Any fraction is rational, okay? Rational numbers also terminate. Or they end. They do not go on into infinity. They at some point end. They can be very long. They can be like 10,000 digits long, but they will eventually end. And then after that, we have terminate, and we have rational numbers will also repeat. So these are numbers that will repeat over and over and over again. In other words, it's predictable as to what it's going to do. So this would be something like 0.123, would be considered a rational number. On the other side of things, an irrational number, I forgot one last thing. So fraction, terminate, repeat. The square root of a perfect square. So if you take the square root of a perfect square, like let's say 4, 9, 16, 25, that will be a rational number. An irrational number, cannot be a fraction. Cannot be a fraction. It will not terminate. So it doesn't end. It is infinite. Oops. Sorry about that. It is infinite. Or it will not repeat. It does not repeat. And then finally, the last one is, of course, the opposite of this. It would be the square root of a non-perfect square. So that is what these ones break down to. Rational, in other words, is predictable. You can predict what it's going to do. It's either going to end or it's going to repeat. Irrational numbers are infinite. You can't predict what they're going to do. They are basically going to go on and do stuff forever. Alrighty, so we're going to take a look at a couple of examples. I need to shrink down some of these things real quick. Give me just a second. Wait, let me grab this one. There we go. Boo! So there's that, and then, woo, let's grab my little blue one here. And shrink this down. And put this up here. Alrighty, so let's go through. We're going to go through each one of these numbers down here, and we're going to decide whether the number is rational or whether it is irrational, and I'm going to color code them accordingly. The very, very first one, pi. This is the poster child for irrational numbers. This is 3.14159, etc., etc. Pi is infinite. It does not repeat, so pi is irrational. The next one, 25 is a perfect square, so this is the square root of a perfect square. This would be rational. 0.333, and then we have what's called, this is an ellipses, which means the pattern here is going to continue, or the numbers here are going to continue. This number is repeating, and so it's predictable, so this is a rational number. 0.375, this is a decimal that is terminating. It ends. Notice there's no ellipses here. So this is also a rational number. 256 over 14. Anything that's a fraction, no matter how crazy it is always, always going to be rational. Next up, square root of 121, the square root. This is a perfect square. This answer comes out to be 11. So this also would be a rational number. Down here we have 0.252525. Again, this is very similar to the 0.333. This is a repeating decimal, so that is going to be a rational number. The square root of 2. 2 is not a perfect square, so this is going to be the square root of a non-perfect square, so the square root of 2 is irrational. This is going to cause a number that will repeat into infinity. 1/3, again, any fraction is going to be rational. This number down here, we have 0.451136421. Can you predict what number's next? No, because it is not repeating. It is not repeating. It is going to be infinite because we see the ellipses here. So we cannot repeat, or we cannot understand what it is doing here. So this number is going to be irrational. Finally, the square root of 20. Again, non-perfect square. We are taking the square root of non-perfect square, so this number down here is irrational. It will repeat into infinity, okay? Again, this is basically just learning how to identify a rational or irrational number. And that's it. Thanks for watching. Bye.